Welcome back. I hope you're feeling awesome. As a part of this video, we'll introduce you to SCD. What is SCD? SCD is slowly changing dimensions. If I ask you a question, how do we store the data in data warehouse? In tables. And extending the question, whatever the data which is there in a data warehouse, will it change? Again, repeating the question. Will the data in a data warehouse change over a period of time? That is the question. Will you recollect the definition of the data warehouse? Definition says data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of the data. What exactly is a non-volatile? Non-volatile means not changing. So you got the answer for the earlier question, right? According to the definition of a data warehouse, the data is not changing. Hold on there. Again, the question is anything on this earth permanent? No, nothing is permanent. If nothing is permanent, do you expect the data in the data warehouse to remain non-volatile? When we said non-volatile, it is for a specific period of a time. As compared to the databases, in data warehouse, data is non-volatile, but it does change over a period of time. That is where slowly changing dimension come into picture. So when I say dimensions, I am referring to the data in a table of data warehouse. Dimensions in data warehouse contain a relatively static data. Static means which is not going to change, like locations, customers, or products. But as we discussed, those dimensions change slowly, unpredictably than following a regular schedule. That is where slowly changing dimensions come into play. So dimensions in the data warehouse are static, but they also change slowly and unpredictably. That is where slowly changing dimensions come into picture. So what is slowly changing dimension then? Slowly changing dimensions are the dimensions in which the data changes slowly rather than changing regularly on a timely basis. That is what slowly changing dimension is. All I'm trying to say is until now we are saying the data is non-volatile. The non-volatile as compared to the databases, but data does change in data warehouse. That is called as the slowly changing dimensions. Slowly changing dimensions are the dimensions in which the data changes slowly rather than regularly on a timely basis. Okay, we understood that data does change in data warehouse. But what are the repercussions of this? When I say repercussions, if the data is changing, is it good? Is it bad? Will that impact the performance of the data warehouse? Or will it impact the quality of the analysis what we are doing in a data warehouse? So what are the repercussions? If you recollect, we have fact table and dimension tables in data warehouse. If any of the dimension is changing, assuming that product is changing in a dimension table, some of the data in product ID is changing in the dimension table. Remember, this product ID is a foreign key in fact table. So it impacts the referential integrity. Means if the data is changing here, it impacts the data here as well. There'll be referential integrity problems. So how do we tackle these problems? To deal with such a problems, we follow SCD management methodologies referred to as type 0 through type 6 SCDs. So with the SCD, we store and manage both current and historical data over a period of time. Whenever you are building the data warehouse, you have to have a due considerations about the SCD. It is one of the critical ETL tasks in tracking the history of the dimension record. So SCD helps us to track the changes in dimension values, and it will also help us to report the historical data at any point of time. So this tracking and maintaining the historical data will be dealt through type 0 to type 6 SCDs. So we have type 0 SCD, which is a fixed dimension. We have type 1 SCD, where we are not maintaining the history. Type 2, we have a row versioning. Type 3, we have a new attribute. Type 4, we have a history table. And type 6 is an hybrid. We will look at all these SCD types as a part of the subsequent videos. Thank you.